Hi friends and welcome back. Today we're going to be comparing fractions using benchmark fractions. Read the word problem with me. Barbara needed 13/4 cups of flour. Her friend Jeanette needed 9/2 cups. And her friend Robert needed 3 6/8 cups. Let's compare the amounts using a number line. But first, let's rename each fraction as a mixed number. The first fraction is 13/4. We can see that 13/4 is greater than 1. How many fourths are in 1? 4/4. So 4/4 equals 1. Let's continue to count by 4/4. 8/4 equals 2. 12/4 equals 3. 16/4 equals 4. We only have 13/4. So 12/4 is one part. What is the other part? 1/4. So we have 13/4 is equal to 12/4 plus 1/4. We can rename 12/4 as a whole number as 3. And then our other part is 1/4. So 13/4 equals 3 1/4. Let's now rename the next fraction, 9/2. We'll rename 9/2 as a mixed number. We'll decompose 9/2 first. Go ahead and pause the video here to decompose 9/2 into a whole and a fractional part, just like what we did with 13/4. Once you're done with this, we'll convert 9/2 into a mixed number. Remember, if you're unsure how to start, think, how many halves are in 1? 2 halves. We'll compare our answers when you return. Welcome back. What is 9/2 as a mixed number? It's 4 1/2. Our third fraction in the word problem is 3 6/8. We can see that 3 6/8 is already a mixed number, so we won't need to convert this fraction. Let's now draw our number line so we can plot each point. We can see that our three mixed numbers are 3 1/4, 4 1/2, and 3 6/8. So what will our endpoints be for our number line? One endpoint can be 3, since they're all greater than 3. And then the other endpoint can be 5, since none of them are greater than 5. Let's draw our number line now. We found that 13/4 equals 3 1/4. Let's find 3 on the number line. Go ahead and imagine between 3 and 4, it's partitioned into fourths. Let's go ahead and mark 1/4 past 3. This shows where 3 plus 1/4 is located. I'll go ahead and label this as 13/4. Please do the same. Our next fraction is 9/2. How many ones are in 9/2? there are 4 groups of 2 halves in 9. So let's go ahead and go to the number 4 on our number line. And how many remaining halves are there? 1 half remains. So let's imagine the halfway point between 4 and 5. Do you see it? Go ahead and mark 1 half past 4. I'm imagining that somewhere around here. Now this is going to show where 4 plus 1 half is located. So I'm going to go ahead and label this as 9 halves. Again, on your number line, do the same. I'd like you to go ahead and pause the video one more time to plot our last mixed number, 3 6/8, onto your number line. As you plot this point, go ahead and explain aloud how you determined where it should be located. I'll be here when you return. Welcome back. How did you plot 3 6/8? Well, I know that in the number 3 6/8, the whole is 3. So I first found 3 on the number line, and then I pictured in my mind where 6/8 more would be. 6/8 is 2/8 greater than 1 half, since 1 half equals 4/8. So I plotted 3 6/8 here on my number line. Let's go ahead and compare 3 6/8 and 13/4. What do you notice? We can see on our number line that 3 6/8 is greater than 3 1 half, and 13/4 is less than 3 1/2. So 3 6/8 is greater than 13/4. The next 2 fractions we'll compare is 29/7 and 31/8. Can we compare these fractions easily? Not exactly. The denominators are different. I think mixed numbers would be much easier to compare. So to compare them, let's rewrite 29/7 and 31/8 as mixed numbers. In the previous problem that we worked through together, we used a number bond to help us rewrite the fraction as mixed numbers. This time, let's use multiplication. We'll start with the fraction 29/7. Think, how many groups of 7/7 are in 29/7? If you need to, count. 7/7, 14/7, 21/7, 28/7. There are 4 groups of 7/7 in 29/7. If this part equals 28/7, what is the other part? 1/7. Again, we know that 28/7 equals 4. And we know the other part is 1/7. So that means that 29/7 equals 4 1/7. Our next fraction is 31/8. Please pause here to convert this fraction into a mixed number, just like what we did with the fraction 29/7. Use multiplication. We'll compare when you return. Welcome back. 31/8 equals 3 7/8. Let's think, how can we compare 4 and 1/7 and 3 and 7/8 using the words a little bit more and a little bit less? We could say that 4 and 1/7 is a little bit more than 4. We could also say that 3 and 7/8 is a little bit less than 4. Let's complete our comparison statement for 29/7 and 31/8. Say the comparison statement with me. 29/7 is greater than 31/8. The next two fractions that we'll be comparing, 5 and 7/8, 5 and 9/10. Think for a moment. Name the whole numbers that these two fractions are between. They're between the numbers 5 and 6. They both have 5 ones. Since the ones are the same, we'll now look at the fractional units to compare. The fractional units is 7/8 and 9/10. Go ahead and pause here to share aloud your thoughts as you compare 7/8 and 9/10. I'll be here when you get back. So, what were your thoughts as you compared the two fractions? 5 and 7/8 is 1/8 away from 6. 5 and 9/10 is 1/10 away from 6. You know, 1/10 is less than 1/8, and that means that 5 and 9/10 will be closer to 6 than 5 and 7/8. Therefore, 5 and 7/8 is less than 5 and 9/10. Here we have the fractions 43/8 and 35/6. Go ahead and pause the video here to compare these two fractions. As you compare, share your reasoning aloud. We'll discuss when you get back. Welcome back. How did you solve? I first converted 43/8 into a mixed number, which equals 5 and 3/8. 35/6 I also converted into a mixed number, and that equals 5 and 5/6. From there, I compared 3/8 and 5/6, since both mixed numbers have the same number of ones, 5 and 5. I know that 3/8 is less than 1/2, while 5/6 is greater than 1/2. So 5 and 3/8, or 43/8, is less than 5 and 5/6, or 35/6. We've arrived at today's problem set. Your must-do problems are here on the screen. Go ahead and set a timer